Hi, good afternoon, everyone.
Good afternoon.
Yeah, so I'm the last person holding you from the party. So I've decided to cut down many of my slides and make it as interactive as possible, and I've added a whole lot of visuals to explain this. So let's get into this, building high productivity apps. I'm Aditya Murkutla. I'm the Principal Product Manager at Progress Data RPM. And so let us see, building it the data scientist way. So first, let us understand what would a data scientist do. So the first quiz. There are two apps. One is a cognitive app. The word cognitive is essentially depicting human-like behavior. Any intelligence that is added to an app is cognitive. So there are two apps. One is cognitive, the other is not. Can you tell which one? So, okay, you're all pointing to the right, so that's the correct answer. And the reason is specifically the box, which is marked in green, which is showing you the advice. It's a buy advice saying that prices are unlikely to decrease within the next 7 days, right? We have all gone through airline websites, compared prices, but the core ingredient here is it's able to look at the history and make a prediction that there's something that is going to happen, take action now, right? So that makes this app cognitive, right? So, but let me give you a more detailed explanation of what differentiates traditional programming from machine learning, right? So I'm using the word data science and machine learning synonymously, and which is accepted. So in traditional programming, we have a certain set of lines of code, which is the program, and then we have data. The data with the program gives you an output, right? Whereas in machine learning, it's the other way around. So you take both the input data, you take the output of the historical, run it through the machine learning algorithms, and let it tell you what will be the rules or what would be the program. So in this case, if you are building a predictive model, the program is going to be a prediction model, right? Once you build this on historical data, now you're passing data, the model gets applied, and what you get is the output, right? So this might seem a little counterintuitive for people who are working on regular apps, saying that I've written code, here's the data, and here's the output. Why should I be training certain thing on historical data and build something which is abstract, here something like a program, which I don't see, but there are certain lines of rules that the machine is finding out, and then I find that I'm applying some input data and I'm getting an output, right? So this seems a little confusing right now, but let's go through the various examples and it'll seem all fair.
Because let's say that program on the left is an Angular application, right? The data is some data in a database. But the image on the right isn't going to spit out an Angular program.
No, not the Angular program. It's the data. It's like you can have data coming from a SQL database or any of the RDBMS data, stuff like that.
Right.
Yeah.
Right. It's just program. It looks like they're the same, but they're not.
No. The concept is that you have certain rules. Simple thing. If I have a mathematical equation, x plus 2 is 4. Right? Every time I put some value, it'll add 2 to that and give me an output. So that's a rule. I'm putting some input, I'm getting an output. But what if I only had inputs and outputs, and I'm trying to understand what's happening in the middle? Right? So that's what the machine learning is essentially doing. Takes the data, tries to understand that, and give you the rules.
Right. I was just making sure I wasn't missing.
Yeah. So data science remains elusive to business apps. Let's go into the detail, but first we have to distinguish between historical analysis and forward-looking insights, right? First, what happens in historical analysis? You have certain data. In this case, I'm taking time series data. So think of it as some sales that is being reported over time. And generally, our instinctive way is to use business intelligence. That is, take a search lens, a magnifying lens, and look through and probably look at sales over time. Because I aggregate it, I can create a sum, I can do an average. I might also say year to date or monthly view, or I can also do drill downs. But anything and everything that I'm doing is historical, right? It's not going to change what's going to happen in the future. I'm only giving more layered view of what has already happened. And I can add many dimensions to it. I can look at it from the left to the right and create a lot of analysis, but it's going to tell me what already happened. So when we are doing forward-looking insights, what is essentially happening is I take the system, take a snapshot over time, and see the system grow and evolve over time, and then say, if this is what happened in the past, let me learn. The machine learning models are learning, and then it'll predict what happens next. So that's the prediction, right? So if these are the things, why is data science still elusive to business apps, right? So the first reason is data science still comes as an afterthought. So for most companies, there's already a UI development team, there's a backend development team, there are system integrators too, but data science is relatively new, right? They have seen companies like Uber, Airbnb use data science, and they know that there's some value, and it's not really clear what that value is or what the data science machine learning component is. So what essentially happens is they start with the in-house team, they start hiring data scientists, and once they hire, they have a new problem on their hands. That is, the app development is happening in one location, a data science team is now working in a different location, and they're not talking to each other, right? They're working in silos. Next thing is different skill set. So if one were to believe that if I'm a backend engineer, will I be able to use machine learning? The answer is yes, if you have the aptitude to do so. But you have to learn certain new skills. The same way, if a data scientist wants to say that I've built some analysis and I want a cool visualization, I want to build a UI for it, can I do it? Yes, obviously. You just have to learn simple things like JavaScript, HTML, and you'd be able to build that. But still, there are different skill sets, and that needs to be acknowledged. And also the tool sets, right? The tools that the app development team is using and the data science team is using is different. And then the data science experiments are not repeatable. So when I talk to most of our customers, and we had interesting conversations where customers say that I have many teams. Each of my teams are using, say, RStudio, Python, and they're building many predictive models or recommendation models on their laptops. Now, once the experimentation is done, they have to hand it over to another team who have to build this in production, right? So that's the last problem. That is, any analysis done, the experiment is not repeatable. So if I have built one model, if I get new data, I'm starting the experiment all over again. And once that experiment is successful, to make it completely production ready, I'm now handing over this entire task to somebody else, right? So is there a solution? Yes. So let us look at the first problem, that how to make the data science repeatable with recipes. So let me take a kitchen analogy. A recipe is like taking ingredients. You give certain cooking instructions, and then you have a tasty dish, right? So the same thing is happening here. You have input data, you pass it through algorithms, and then you have the results. And the whole thing is now put into a template that is reusable. So if I'm a data scientist and I build a recipe, I can hand it over to any other data scientist who is using this platform. I can export it, import it in a different system, and all the new person has to do is connect to input data. The recipe will do all the things that are meant to do, and it will give you an output. Right? So now I'll give you examples of what various recipes are. So data RPM brings a whole lot of recipes out of the box. So some of them are like segmentation recipes, which do clustering, distributions, influencing factor recipes. So prediction. So for prediction, we have classification, decision trees, random forests. So this might seem little daunting, but now I'll explain each of this recipe in a way that is very simple. A segmentation recipe is essentially explained here. So if you have a new smartphone that is launched exclusively on an e-commerce app, so something like Amazon, right? So what would the customers on this e-commerce do when they have to send specific apps when a new mobile phone is launched? So you don't want to just target anyone and everyone who's using this e-commerce app. So what you have are a whole lot of people. So the idea is to run segmentation so that you are able to segregate people into groups and then label them. So this group of people are deal hunters. So this group will only be interested in buying your phone if they see some discounts. The second group are like the typical window shoppers. So they'd come, look at the product, add something to the cart, and abandon it. Right? The third are the gadget geeks. These are the people who have their eyes peeled, looking at Samsung, Apple. Every time there's a big event in Cupertino, they would go and buy the phone. Right? So these are the people whom you would want to sell the phone to. So once you are able to segregate the customers, you will be able to target them. So this is the segmentation recipe. The next is the influencing factor analysis. So this can be best explained through market basket analysis. So when you go to any supermart, retail store like Walmart, you have a basket and you keep adding items to it from the shelf. Now, if we were to take a historical analysis of what people have been adding to the basket in the past 1 year, what you'll know is some interesting insights like this would come up, where people who bought milk have also added bread to their cart, and that's 71% of the time. People who bought milk have also added eggs to the cart, and that's 43%. Right? So you'll have these kind of rules come out from influencing factor analysis, saying that these combination of things are occurring at this frequency. And when I'm giving these examples, these are for illustration. The same algorithms apply easily in any other sector or any other vertical. For example, when Dimitri was giving the CTO talk this morning, he was talking about the no-show app in healthcare. And there we were able to run the influencing factor analysis to find out what are the characteristics of patients and who are these people and what factors are deciding whether they won't show up to the appointment. For example, some of the factors that came that people of certain age, people from certain region, people who have to travel certain distance, these combination of factors are leading to an event, right? The third one is prediction. So here I'll take an example of logistics. Here you have a cargo truck that is delivering consignments. And here are certain predictors that might help us understand what is going to happen next. So when we make predictions of whether a consignment would be delivered on time or there would be a delay. So one thing could be the size of the consignment. Is it a small box, medium, large box? The distance, does the truck have to go 100 miles, 1,000 miles, things like that? Or the weather, is it sunny, rainy, or is it snowing, or the fog. So many of these predictors have, for simplicity, I've only used 3, but you can think that there could be 100 such features or predictors which are used to build a prediction model. And finally, when the delivery guy comes, you are able to make a prediction that this will be an on-time delivery, or this would be there would be a delay. Right? And again, the same thing. This kind of the algorithms that are gone into this example can be extended to any business app, any vertical. It could also be applied to insurance claims, as shown in Yogesh keynote address, where there are insurance and there are claims, and you're showing what would be the rate of a claim being accepted, right? The concept still remains the same. So once you have an algorithm and you package it into a recipe, you just have to introduce us to those kind of use cases, and we'll tell you these combination of recipes will help you. And that's the next part. Once I have these core recipes, I've shown you examples of 3, but there are many more recipes that can be used as your tools in your toolbox. And we also have the building blocks to build something which is already production ready. So you have a drag and drop feature where you drag items like connectors, drag items like recipes, connect all of them in a workflow, and all you can do is say the output also goes to a micro app. So all these connections are done. You can also schedule when this thing would run. So you can say this scheduled to run every day at 6 a.m. in the morning, and new data comes in, I'm making predictions, and that goes to my app, right? Yeah? Yeah. So I'll give you the example of the healthcare app which we built recently, the no-show app. So there, as a product manager, my job was to bring all the people onto the same page. So first, we got the requirements saying that from our discussions with prospects, we understood that these are the requirements and this is what would be needed to build the app. The immediate next step was to bring in a UX designer and ask him to have conversations with the prospects, saying that what should be the layout, what should be the entire user journey, what should be the navigation, right? And at that point, we also included our data science lead, Ashu, here, who talked to the prospects and understood that if I'm introducing this at an app level, so do I want to have a screen where I say, I built a prediction model, I want to show the predictions, right? In the demo in the morning, when Dimitri was showing that there is a no-show risk, he was giving a percentage right next to it. And that was what the designer said, that the consumption layer has to be very abstract. So here we don't want the healthcare users to be understanding that, okay, there is an algorithm that ran in the backend. Right. So rather, the consumption layer should be very simple. So when you click on it, all it shows is a patient name and a risk percentage right next to it. The risk percentage comes from the data science algorithms, right? And the UX designer took the call that it should be how it looks, so that anyone who's using the app is finding it very convenient to consume that. Yeah, so the data scientist is building the solution, saying that what you're asking for, this is how it will be done, and this is how you'll use it. So let us take the other example, that I didn't introduce the data scientist to this picture. Right. So then I would have the designer, a backend, and the UI developer build the app. And 3 months, 4 months, once this app is deployed onto the customer site, then I bring in the data scientist. So just imagine what that would look like, right? So then so what he would then do is give me all the historical data, and he'll do the historical analysis, because there is no way he can influence the app. So he'll do a historical analysis and say, this is what your patients did in the last 1 year, last 3 months, or last 4 months. There's nothing that he can do now to influence the app or change any feature in the app, right? So then what you're essentially looking for is a major version change where you have to add certain other things to your app to be able to show the predictions, right? So it's all about whether you want to integrate that part into your app well in advance, or you have to do it at a stage sometime later. By then you have already decided on the architecture, you have already decided on how many hours you have already spent building the app, right?
Okay.
So this is the completely integrated cognitive offering. So until today, Progress Data RPM has served a whole lot of customer use cases, and we are doing it standalone. That is, whoever was approaching us, we are solving their problems with the platform. And now with the Progress Kinway, we have integrated with Kinway Studio, Kinway Platform as a Service, and then we also have this. So now let us revisit the original problem that data scientists and app developers are not able to collaborate together. So with this integrated offering, you can have each person, each resource work on the platform. So it's all same platform, right? And then you can have the Kinway Studio to develop the front end, and then Kinway obviously, and Data RPM for the data science. And then you have the UI, which is essentially wizard based for both Kinway Studio and Data RPM. So that means that for a first pass, that's for a proof of concept or anything that you are trying out, you don't even have to write even any one line of code, because you have a wizard which is saying there is a drag and drop interface, this is the form, this is how the UI should be, and you're set. Kinway is anyway taken care of when we are building data science solution, so that will come out of the box. So this is a templatized thing. So the first template that we have offered is the patient no-show app, which has all the three integrated into one template, and that is coming out of the box. And we are building many such solutions. So if you have any use case that is burning and you want us to address that first, let us know. We'll add that as a item on our roadmap. And next is the skill set. The people who want to go deep, that is, get into the roll up their sleeves and get into the nitty-gritties, they will be able to address the things using JavaScript, HTML, and the same person can also use Kinway backend because it's also using JavaScript on Node.js. And then Python and Scala are optional. If you use the wizard-based recipes on the connectors, you don't have to write anything. But if you're interested, you want to develop your own recipes, or you want to extend the existing recipes, it's possible. And of course, the infrastructure is fully managed, right? So you don't have to worry about, I've done this in a dev environment, and now I have to move it to a production environment. All you have to do is switch in Kinway, and everything is moved from dev, migrated to a production setup. So this essentially, for the first time I've seen that we have worked with many customers, and while I've talked to many prospects, what I've learned is that there are tools in the market like Microsoft Azure, Google, which does offer many building blocks, but no one is actually given a complete solution which says that here is a template that will allow you to build UI, backend, as well as data science, all put together in one single offering. Right? So coming back to the vision of Progress, the future of business applications is cognitive first, and we will provide the best platform to build and run them. So this is the overarching point that I'm trying to make, that when you're building an app, don't let data science be an afterthought. So think of it while planning an app, because obviously when people are talking about stuff like, oh, only if I knew that I could have done this well in advance, right? So the planning, everything decides your architecture. So if you have gone with a big data solution, you have already bought Cassandra, you've already gone to MongoDB, And then you decide that, oh, now I have to run data science, and you're looking at Python-based models, scikit-learn models, TensorFlow, and then you say, oh, I already have my architecture, right? So what do I do with this? You can't just toss off one item and bring in the other. Then you will have integration issues. You will have problems with models talking to each other. So those are a whole lot of technical things that we could talk at the booth. We have the Kinway booth. And I'll be happy to show you how we built this patient no-show app, integrated the UI with the backend, with the data science, all using one platform. And so open to questions.
Anyone else? So cognitive first, I think that's very, so you gave kayak as your first example, which is, so, in that example, I mean, to me, what I saw was, hey, this is a percentage that's going to go down. And if they didn't have that little box, it wouldn't have made that big a difference.
Yeah, so then it would just be an aggregator. So all it's saying is, here's American Airlines, here's JetBlue. I've just done a backend integration. So I'm able to take all that and show you in one UI. So that's convenient. That's nevertheless convenient. But yeah, Google is anyway doing that. You could have done a Google search on flights and you got it listed there. Why do you need another app for that? But the interesting part that Kayak did is gone through the historical data and made a prediction, and then it gave a recommendation that is actionable. That's the important point.
Because if you have a price-sensitive customer who's trying to time the best time to buy an airline ticket, which is ridiculously hard to figure out when is the best time to buy it, that would probably be a useful item to that person.
Sure, I can completely see how this is good, but I'm not completely sold on cognitive first, and that, I mean, I agree things need to be smart, but can you sell me a little bit more on why cognitive first is just going to be so important? I mean, I get that things need to be smart, but you can still build a lot of apps and still have a lot of usefulness without cognitive first being there.
Yeah, sure. So the whole point is the wow factor that you're giving to the customers. Are you competitive enough in the market? So if the example that I gave on the left side, obviously I couldn't show the name of that, but all that did is you go to the website, you fill the form. So that you gave your name, this is a start point, this is the destination, fill the form, and then you got airline options. You chose one and purchased, right? Is that good? Or the wow factor is essentially saying, what if I'm dilly-dallying, I come back after 2 days, and then I see that the prices are double, right? I don't want that to happen. So if there was an app that told me that don't delay, so take it now. So the same thing happens on Airbnb too. So if you have a priority, if you're a priority customer, and then there's a star host, right? That house is going to be taken. So if you're going for a holiday in Paris, you know that most of the hot properties are going to go out. So if there's an app that tells you that make the decision now, or say that winter is coming, so wait for some time, the prices will drop down. So anything can happen. So it's not only in one direction. That gives an extra incentive for the app user to engage and come back to your app. So that gives you a distinguishing factor, saying that why don't I go to somebody else is because this is cognitive. It's also giving me feedback that's allowing me to take decisions. So any other questions? Okay, thank you for all for joining. So we have one other session that's tomorrow by Ashutosh Mani. He's a principal data scientist, and he's going to talk about transforming healthcare with AI and ML. Do attend that session too. Thank you.